Okay, let's go over linear relationships assignment day 4. Okay, so number 1, Jen paid $6.75 for 9 pounds of apples. What is the cost per pound of apples? Okay, so per pound, it wants to know the cost per 1 pound of apples. So what we'll do here is we're going to take $6.75 and divide it by 9. Okay, so I've got 6.75 divided by 9. So top number goes in the house. So we've got 6.75 divided by 9. Okay, so there's no decimals on this outside number here, so we can just bring this decimal up here. Remember, we're dividing because we want to find the cost per 1 pound of apples. Okay, 9 cannot go into 6, but 9 can go into 67. 9 times 7 is 63. Okay, so 6 minus 6 is 0. 7 minus 3, or I did it backwards, but 7 minus 3 is 4. 6 minus 6 is 0. Bring down that 5. Okay, 9 can go into 45 5 times. 5 times 9 is 45. Okay, so then we're done. Okay, so for 6.75 divided by 9 is 75 cents. So it costs 0.75, which is also 75 cents per pound. Okay, so anytime it asks per pound, per something, wants to know the cost per 1, we're going to divide. Okay, number 2, Kenesha bought a plant that was 8 centimeters tall. It grows 1.5 centimeters each week. There's a key word there, each week, each multiply. Represent the relationship between the number of weeks and the height of the plant. Okay, so X is our number of weeks. Okay, and Y is our height of the plant. Okay, so you have to start and say, did it start at 0 centimeters when she bought it? No, it started at 8 centimeters when she bought it. Okay, so when she bought it was week 0, and it was 8 centimeters tall. Okay, then each week it's going to grow 1.5 centimeters. So on week 1, it's going to be 9.5. Okay, week 2, it's going to be 11. Week 3, it's going to be 12.5. Week 4, it's going to be 14. And the way I'm getting that is I'm just taking this number, I'm adding 1.5 every time because it's growing. Each week, it's growing 1.5 centimeters. Then that last week, 5, is going to be 15.5. Okay, so now let's graph it. Okay, so the title would be Plant Growth. Okay, we're going to put our weeks, our time in weeks down here. And then we're going to put our height here. Okay, so then we just start graphing it. So at 0, it was 8 centimeters. At week 0, when we bought it, 8 centimeters tall. And then week 1 is going to be 9.5, and I'll put that in that line between the 9 and the 10. Week 2 is going to be 11. Week 3 is going to be 12.5. Week 4 is going to be 14. And week 5 we can't plot because it is not on the graphs. And then right there is our line. Okay, so now it wants us to write the equation to describe the linear relationship. Now, when you write an equation for a line, remember it's y equals mx plus b. M is your slope, which is your rate of change, okay, how much it's increasing, and B is where it crosses through on the y-intercept, okay? So B is always easy to find. Here's your y. You just look to see where it crosses through at what number. So it crosses through at the 8. So our B is going to be 8. Excuse me. Okay. And then remember, I'm going to come over here because I have more room. Your M, which is your slope, is your change in Y over your change in X. Okay? So the change in Y each time, what does it go from here to here, from here to here, from here to here, from here to here, is plus 1.5. So we've got 1.5. Okay? Then our change in X, which is here, is just 1 every week. And I tell y'all, any number over 1 is just itself. So our slope is 1.5. So we have Y equals 1.5x plus 8. That's our linear relationship. Y equals 1.5x plus 8. Okay, let's go to this one. Is it proportional or non-proportional? Remember, the only thing you're looking for if it's proportional or non-proportional is if it goes to the origin. If it goes to the origin right here, it's proportional. If it does not go through the origin, which this one does not, it is non-proportional. All right, pause this video at any time. All right, number 3, Mary has $75 in her savings account and will deposit, that's a big word, deposit, not a big word, it's a important word, we need to know what it means, 50 each week. Oh, each. Adding to each. Represent the relationship between the number of weeks and the balance in her account. Okay, so X is the number of weeks, just told us up here. And the balance in her account, so we'll put account balance, A-C-C-B-A-O, account balance. Okay, so on week 0, when she opens the account, okay, she starts with how much? She starts with 75 in her savings account. So week 0, she has $75. Okay, and then each week, how much does she deposit? She deposits $50 each week. So as the weeks go up, it's going to go up by 50 each time. Okay, so week 1, it's going to be 125. I'm just adding 50. 75 plus 50 is 125. 2, it's going to be 175. 3, it's going to be 225. 4, it's going to be 275. And 5 is going to be 325. Okay. So now we take this, we fill this out. We'll just title it savings account. Okay, and put time in weeks. You could just put weeks, that's fine. And then account balance. So her money over here. Okay. So at week 0, so when she started, she opened it up and she had $75. So at week 0, 75. And then at week 1, 125. Week 2 is 175. Week 3 is 225. Week 4 is 275. Week 5 is 325. Oh, I didn't do a great job of connecting my dots. Sorry about that. All right. So here it says, write the equation to describe the linear relationship. So Y equals mx plus b. Okay. So b is pretty easy to find out. Remember, b is where it crosses through your y. So if you're looking at a table, come look where it crosses through right there. I mean, if you're looking at a graph, sorry, look at where it crosses through the y-intercept. Or if you're looking at a table, find 0, because 0, okay, we go 0, 0, and then your y is your y-intercept is 75. See? So this is that right there. Okay? So our b is going to be 75. Okay? And then our m is our slope. And remember, our slope is our change in y over change in x. Okay? So m equals, what is our change in y each time? Does it go up or go down? It goes up 50, right? So it's going to be positive 50 over, and then our change in y each week is 1. And we've said any number over 1 is itself, so m equals 50. So we come over here, y equals 50x plus 75. Now, is it proportional or non-proportional? You're looking, does it go through the origin? If it goes through the origin, it's proportional. If it does not, it is non-proportional. And in this case, it does not go through the origin, so it's non-proportional. Okay. Number 4. I don't know why this is jiggling so much. I'm sorry. The table represents a proportional relationship. Find K and write the equation represented in the table, represented by the table. Write your answers. So when you're trying to find K, which is just your constant, how much is it increasing by each time? Remember, y equals kx. Okay, we did this. Y equals kx. And if you're looking for your K, you divide x, divide x. So K equals y divided by x. So we're just dividing every time. We're dividing, okay? So we're going to take 195 and we're going to divide by 3. Okay, so I've got 195 divided by 3. 3 will go into 19 6 times. 6 times 3 is 18. Subtract here. 9 minus 8 is 1. Bring down my 5. 3 will go into 15. 5 times 3 is 15. Okay, so here we have 65. Let's see if it's the same. Oh, sorry. Here we have 65. Let's see if it's the same here. So I've got 325 and 5. I'm going to divide 325 divided by 5. Okay. 5 will go into 32 6 times. 6 times 5 is 30. Subtract. Bring it down. 5 will go into 25 5 times. 5 times 5 is 25. So 65 here. We want this all to be the same. So we've got 585 and 9. Okay. 9 will go into 58. 9 times 8 is 56. Right? No. That is so not wrong. That's so not right. 9 times 6 is 54. How about that? Yeah, that's way better. Way to go, Miss Harris. 9 times 6 is 54. See, even math teachers. Bring that down. So 65. So it looks pretty constant to me. We could go and divide that one, but it's looking pretty good here. So K is 65, your constant. And if y equals kx, like we said here, our K is 65. Good job.